Going to look into a rate of reaction question with a little bit of mole concept, and that's to identify limiting reactant. Now, hold on there, because limiting reactant, although it's a very simple concept, can be quite difficult for some students because they do not know how to get started. So let's get going with this one. So we have this question here. This question is essentially, you can see from the setup, right? This is a very common practical that you get to do in school. We start with magnesium ribbon and then we add it into acid. So when we have metals and acid, you end up with a salt. I'm going to write in purple. Okay, so we have our salt and hydrogen gas. Now this is a very common one, so you do need to learn how to write the balance equation. The common error that I see here is the formula of the salt. Magnesium is group 2, chloride is group 7. If you crisscross, the salt formula will be MgCl2. They have balanced it very nicely for you, so take note of that. Okay, so that's only 1 mark. The second question needs you to identify the test for hydrogen gas. Only 1 mark here. You need to identify what you are using. That would be lid splint, and the observation would be the second part here, would be this lid splint will actually extinguish with a pop sound. Some students like to use the word or include the word squeaky pop sound. That's fine as well. Okay. In fact, it might be a better idea to include the word squeaky. Right. Another word for lid splint is lighted spin. Both will get you the mark. But for this is a 1 mark question, you need to answer both parts to get the full 1 mark here. All right. Moving on. This is the mole concept question. So the student uses this mass of magnesium and they tell you there is this mole of hydrochloric acid. You want to show by calculation that the acid is in excess. Now, the only way to compare between the reactants is using mole. Okay, so you can only use mole, number of mole, to compare. So you want to convert the mass of the magnesium to mole first. So mole, you need this triangle, mass, mole, MR. Okay, so in order for you to find mole, you have to use mass, which is over here, divide by the AR. What's the difference between AR and MR? AR is used for element or atoms, whereas MR refers to molecular mass, so that's referring to like compound, etc. Okay, like for example, MR of CO2 is a compound because it's made out of carbon and oxygen. In this case, we are only looking at magnesium, which is an element. So you can actually get the value of this magnesium using the periodic table. So that's 24. So you'll see that this number of mole of magnesium is 0.00375. And how do you compare here is you actually need to go back to the balance equation, as we can see here. The ratio of magnesium to hydrochloric acid is 1:2. How do I get 1? Okay, now in chemistry, the value of 1 is never written out. So there's actually, if it's balanced like that, it means that 1 mole of magnesium needs to react with 2 mole of hydrochloric acid. And this is how I would get this ratio of magnesium to hydrochloric acid. This is based on balance equation. Okay, so what this means is if I have 0.0375 mole of magnesium over here, then I will need double that mole of hydrochloric acid, which is 0.075 mole of hydrochloric acid. But I need this. But what do I have? I actually have a lot more. I have 0.025 mole of hydrochloric acid. Because what I have is more than what I need, then my hydrochloric acid would be in excess. Okay, so this goes to show that the hydrochloric acid is in excess, and that's how I prove this 2 mark question here. Okay, hopefully this helps. If not, revisit this question again or relook this question again. If you have any question, feel free to drop me a DM. Okay, for more concept question, a lot of graph plotting. So if you follow through all of this, you will get a plot like this. Okay. So you will need to, for this question, you need to find the volume of hydrogen gas collected in the first 10 seconds. You will need to show on the graph. Now, this is when I need you to be really, really clear that you need to show you're working on the graph. You cannot just write down a value here. Even if your value is 30, you only get 1 out of 2 marks, okay? So what you want to do here is you go to the time and you identify 10 seconds. This is where your 10 seconds is. And then you draw the dotted line upwards. Oops. Hopefully it's not Okay, yeah. Okay, so my 10-second is here, and you draw this dotted line upwards. Once you hit the curve, you draw towards the left-hand side, and you should get a reading. So for me, the reading is 30. So that's how I get this. Okay. So if you are not able to annotate on your graph, then you will not get your first mark. Okay. To show on the graph means that you need to draw the dotted line until you hit the red color curve and you read on the value on the left hand side. Okay, so take note of instruction like this. This is how students tend to lose marks. Okay, next one. I'll explain why the rate of reaction is the greatest at the start. Now, how do I know that the rate of reaction is the greatest? I actually have to use the gradient. You can see from the graph, the gradient is the steepest in the beginning, and you need to be able to explain why. So again, why is the gradient so steep in the beginning? It's only a 2-mark question. The reason is because the reactant is in its greatest abundance, or the concentration of the acid is the highest in the beginning. Okay, so that translate to highest frequency of effective collision. Now, some of my students, they don't like the word effective. You can change it to successful. Both ways will still get you the marks. Okay, when it comes to rate of reaction, you need to discuss in terms of time. Okay, so you will need to have the word frequency in your key phrases. So we use the word highest frequency of effective collision or highest frequency of successful collision at the beginning in this case, because we want to answer back to that question. All right, so that's our 2 marks there. And finally, we want to okay, so there's this question like I think I missed up. So that conducted at 5 degrees higher, draw on the curve that you would expect the student to obtain. Now, if we are conducting an experiment at higher temperature, then the rate of reaction is going to be faster. But maybe before I draw this, I'll look into the explanation question. Why is it that the rate of reaction actually will be faster if we increase the temperature? 3 marks here. This is the hardest one to score in terms of all the factors affecting rate of reaction. When it comes to temperature, you do have one extra step that you need to explain. So the first one here, most of them will be able to get it, is that if you increase the temperature, the kinetic energy of the particle will increase. What it means is the particle will actually move faster. Just saying that the particle will move faster will also get you the first mark. Okay. Next one, and this is the hard one. So I'm going to put a asterisk, put a smiley face. Okay, what does it mean to have higher kinetic energy? Is that it means that more particles right now will have energy equal or more than the activation energy. So if you kind of pause a while and think about it, activation energy is the minimum amount of energy required for a reaction to start, to turn the reactant to product. Okay, so if more of your particles have energy higher than the activation energy, like they are like at this stage right now, okay, then it's really super easy for them to turn or to become a product. Okay, so that's what point number 2 means, and that's actually the one that most students tend to lose their marks in. But students will be able to again pick up the 3rd mark here. It's saying that now that the particles have more energy than the activation energy, there'll be a higher frequency of successful collision or higher frequency of effective collision, leading to increased rate of reaction. This is another way to structure your 3rd point if you want to. Okay, so I'm going to go back to this question here. On the grid, draw a curve that you expect a student to obtain if he is conducting the experiment at 5 degrees higher. So what's going to change here? I'm going to use purple, or maybe I use pink. Okay, maybe that's too close. I should use green. Okay, is that my rate of reaction would be steeper, and then I would probably end at our flat line or level off earlier. Okay, but my level off will still be at 88 cm. Okay, so flat or level, sorry, I should put this level off or flat line earlier than the original rate, and then it would be gradient steeper than original curve. Okay, so this is how we mark, or rather give your the marks here, you can see that it's a 2-mark question over here. Okay, it's a 2-mark question. So first we need to see that the gradient is steeper, followed by the flat line at the top. It level off at an earlier stage. Okay, so there's a 50-mark question on rate of reaction. Is it too fast? If you find that the limiting reactant questions it's a little bit confusing, again drop me a message. I'll try to find a similar question on limiting reactant. Usually limiting reactant can go a little bit higher in terms of proving. It can be 3 marks. I've not seen a 4 marks, but 3 marks I have seen quite often. So if you need a little bit more assistance in that, please let me know. Drop me a DM. I'll be happy to explain to you in details. All good.